In the world of probability, a lot of times we use these contingency tables, otherwise known as a two-way table. Two-way because there's one variable here, the type of scout, and there's one variable here, the self-esteem. Now you may be looking at something that's really disappointing. Why is it that so many of the Boy Scouts have such low self-esteem? Well, I'm glad you asked. We could sum that up in one word. That word? Popcorn. When the Girl Scouts set up their tables outside the grocery store and they're peddling Girl Scout cookies, everybody loves them. Finally, it's that time of the year, give me 10 Thin Mints. I love these things. But when the Boy Scouts set up and they're trying to sell their popcorn, not even their own mothers like the popcorn. People walk by, sorry kid, I'm not interested. They learn dejection from an early age. We got to stop the popcorn, but that's another story for another time. Let's investigate what can happen with this contingency table. One of the first things I want us to understand is the meaning of the word and. For right now, we're only going to select one thing. When one thing is selected, the word and means intersection. And it looks like this. This is the intersection sign right here. Later, when we select two or more things, the word and is going to mean to multiply. So it's very important in probability. The first thing you should look at almost every time is how many things were selected. If you select one thing, the word and means intersection. So in this case, what if we said event A was you're going to select a Girl Scout, and event B is that this scout has high self-esteem. So what's the probability that we randomly select a scout and it is a Girl Scout and they have high self-esteem? The word and means intersection. You simply go to the intersection of all the Girl Scouts and all the kids with high self-esteem. That's the only group that's both simultaneously, so it's the intersection. So our answer, this probably is going to be 70 out of 200, because what we can do with these contingency tables, add up the rows. When you add this up, you get 100. When you add this up, there's also 100 Boy Scouts. Kept the numbers simple this time, just for the sake of simplicity. But altogether, there's 200 kids. So the probability of getting a Girl Scout and someone with high self-esteem, that's 70 out of 200. Now the word or. The word or means to add up, to add things together. And or, unlike in English, where if we say, hey, we're going to the movies or we're going out to dinner, it means you're doing one or the other, but not both. In the world of mathematics, the word or is an inclusive or, not exclusive. So if we say we're going to go to the movies or go out to dinner, we can do one or the other, or we can do both. That's why I love mathematics. So or means one or the other or both. So in this case, if we said, hey, what's the probability that we select a person and it's a Girl Scout, or this union sign is the word or, the person has high self-esteem, then all you have to do in the contingency table is just go select anyone who falls into one or both categories. So then we can say, oh, just add these up. 10 plus 20 plus 70 is 100, plus 10 is 110 out of the 200 kids are either Girl Scouts or they have high self-esteem or both. Now, in the world of mathematics, we also have to pull in really ugly-looking formulas to make things more confusing. It's job security. All right, so what this means is the probability of A happening, in this case, let's say A is, again, a Girl Scout, or B, that they have self-esteem. Well, you can follow the formula. You first of all take the probability they have a Girl Scout, which is 100 kids out of the 200, plus the probability they have high self-esteem. There's 80 kids with high self-esteem out of the 200. But then, that's clearly an 80, all right, 80. Then you subtract from that the intersection. There are 70 kids that are in both groups. So now what happens here is you add this up and you subtract it all away, but then you know what? You get the same answer, 110 out of 200. So why is it that this thing was subtracted away? Well, again, glad you asked. Because the intersection got counted twice. These 70 were among the 100 Girl Scouts, and these 70 were also among the 80 with high self-esteem. That's why the formula had you subtracting them away. So either just add them up inside the contingency table or use the formula. Either way is fine. Then we get to the conditional probability. And these can be a little rough on the brain. Right there, that looks kind of intimidating, I think. But here's how this is read. Again, let's go with A being Girl Scouts and B being a scout has high self-esteem. And the way you read this is the probability in this case that you get a Girl Scout given that, this So that is the meaning of this little vertical segment, given that the person has high self-esteem. So this is the probability that we're trying to find. Now, if we use the formula, we're going to say, okay, it's find the intersection, which we already found was 70 out of 200. So we're saying, okay, we had 70 kids out of 200 that are both Girl Scouts and have high self-esteem. Then divide by the thing that was given, which is that the person had high self-esteem. Well, the probability that someone has high self-esteem is those 80 kids out of the 200. So we divide this out, and our final answer, after you do a little math, is going to be 70 out of 80, or just 7/8. So that's your conditional probability. Now, there's a way that works that I think is a little simpler, especially if you're given the information in contingency table, and that's this. We could say, all right, let's shrink the sample space from the 200 kids that we had initially down to just the kids that obey the information that was given. We were told that the person selected had high self-esteem. We're trying to find the probability we got a Girl Scout given that they had high self-esteem. So you shrink the sample space down to only the people that can have the given information associated with them, the people with high self-esteem. That eliminates this whole group here, and it brings it down to just these 80 kids that have high self-esteem. And out of those 80, what's the probability that you get a Girl Scout? Well, that would be 70 kids out of the 80. So shrinking the sample space down, in my opinion, is a lot easier than following the formula, but again, you should be comfortable doing both. All right, would you please look this over, try to get these two probabilities, paying attention to the conjunctions. Look at that math teacher that knows the conjunction, and see what you got. So once again, I repeated this one. I meant to change that to low, but we'll do this one again. The Girl Scout or high self-esteem, remember that was here, or here, or here, or here. You added them all up, you got 110 out of the 200. Now this one, what's probably get a Boy Scout and someone with low self-esteem? Well, that person had to obey both those characteristics, so it's the intersection of Boy Scout and low self-esteem. So that would be those 80 kids right there. So this probability would be the intersection. That's 80 out of 200. Now, when you go here, what I'd like you to do is read these through real quick and realize that all three things are asking for the exact same probability. It's conditional. So the way we'd write this symbolically is, what's the probability the person has high self-esteem given that it's a Boy Scout that was selected? So this is how we would write that symbolically, and it can be read either of these three ways. So let's shrink the sample space and then we're done. We know that the person we selected was a Boy Scout, so that shrinks it down to just these 100 people. So out of those 100 people left in our sample space, what's probably they have high self-esteem? That would be those 10 kids out of 100. So 10 out of 100, or 1/10 conditional probability, and that's the beginnings of the probability unit.